Oh yeah, right now we're waiting for the next speaker, and his name is Vladimir de Turckheim. Yay, you're here.
Hello.
Yeah, hello. We don't see you.
You don't? Let me turn the cam on, and that's
No,
better.
no, it's better for sure. So tell us maybe a little about yourself, and we are good to go.
Okay, so I'm Vladimir de Turckheim. I do Node.js security full-time for a company named Sqreen. I've been developing with Node.js for the last 6 years now. And that's a technology I like a lot. And 2 years ago, I've been really humbled and honored to have been nominated to get Node.js commit rights. So for the last 2 years, I have been a Node.js collaborator.
That's amazing, really. That's really amazing. Okay, good. So I suppose you may start, and as usual, after the Vladimir speech, we're going to have a Zoom chat where you can ask him. Where you can ask him any questions you want, and I'll send a link to the chat. So for now, yeah, you may start. Wish you luck.
Thank you very much. So let me start by sharing my screen, and it should be good.
Yeah, it's good.
Awesome, thanks. So let's go. My name, thanks a lot for coming today. I will give a talk about fighting memory leaks and CPU bottleneck in Node.js, because it's an important topic, and I realize that most people learn they need to know about it when it's too late. I often have people who ping me and ask me about these topics when they start to have issues in production, and they are usually in panic. So the goal of this talk is to give you the basics of worst case scenario debugging in Node.js. So if, and I hope it never happens to you, but if it happens to you, eventually you know what will be the first step to save your prod. As mentioned, I'm Vladimir de Turckheim. A couple words about Sqreen. Sqreen is a tool that provides security for web applications. So we protect Node.js application as long as other technologies. It's really easy to install. So if you have any production, any server in production, you might want to check what we do. That's probably interesting, and it's pretty easy to use, and we block attacks and detect attackers. Also, feel free to follow me on Twitter. I'm trying to get more followers than my CEO. I'm 100 followers short, so please help me win that fight. Disclaimer, this is my first online talk, so first time I give a talk from home, first time I will do this kind of talk, and I will do live demos, so anything can happen according to Murphy's Law. Let's hope for the best, but I planned for the worst. What is this talk about? That's a good question. This talk is about application crashing, maybe. Slow web application, probably. Weird stack trace, we will see what it is about. And unicorn, because I'm alone, locked down in my apartment, and my only friend is this stuffed unicorn. So I figured that you wanted to see my only friend for the last few weeks. We'll start with the first part of the talk, which is probably the most important one, which is the intro to the Chrome DevTools. And I won't even tell you about how they work and how to use them in this part. I will tell you the only thing that's important, how to connect a Node.js instance to the Chrome DevTool. So let's start with a story. Something weird is happening in your application. It can be anything. It can be your application being slow. It can be your application crashing. It can be anything. But something weird happens, and you want to know what's happening, and you have no idea. You just have a few symptoms that might be logs, that might be your monitoring solution telling you things. You don't know about it. What do I do? Then that's probably when you need to know about the Chrome DevTools. They're available in Google Chrome, and they use a communication protocol named the Chrome DevTool protocol. This protocol is all documented online. It's pretty interesting. And this protocol enables you to debug anything that happens in Google Chrome, meaning you can debug the DOM, the HTML page, or the 8. And basically, when you open the developer tools with right-click and inspect on Chrome, that's what happens. It opens a client for the Chrome DevTool protocol. And right now, you must be wondering why I'm talking about Chrome, because this is a talk about Node.js in a Node.js track. And you are right. But Node.js, one of the main components of Node.js is V8. V8 is the JavaScript engine that runs JavaScript into Node.js, Chrome, and Chromium. Meaning that when you run Node.js, all the JavaScript code you write is actually interpreted by this piece of software developed by Google named V8. And that's the virtual machine where JavaScript runs. It's responsible for calling the function, garbage collection, handling the life cycle of every object. So we will use the Chrome DevTools, CDT in short, to debug the V8 instance of the Node.js process. So indeed, there is a Node.js process to use here. And you can't just take any Node.js process and connect it to the DevTools. You have somehow to tell the Node.js process, hey, I want to use you with the DevTools. Would you mind to collaborate with them, please? There are multiple ways to do that. And the easiest and most straightforward one is to start the process with the flag -- inspect. So instead of starting your process with node server.js, you would start your process with node -- inspect server.js. And at this point, you will see two more logs to your usual application. The first one will be debugger listening on WebSocket, blah, 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 blah. And for help, see https://nodejs.org documentation inspector. What's interesting here is the first line of log. Debugger listening on WebSocket localhost 9229. This means that the Node.js process is now opening a WebSocket server, like you would do with socket.io or the WS module. But this WebSocket server actually is expecting someone to talk to it using the Chrome debug protocol. Meaning that if you've got any WebSocket client, which is basically an upgraded HTTP connection, and you know the Chrome debug protocol, you can start to debug the instance. And that's what the Chrome DevTools do. They connect through WebSocket to an instance of V8 that listens to this WebSocket. And before we go to the demo of this part, I wanted to show you another way to tell Node.js to go in debug mode. What if the process is already started? Because in our previous example, we started the process with the -- inspect flag. But sometimes the process is already started and you cannot restart it. Let's say you are in a cloud in the Kubernetes environment and you don't want to change your deploy mechanism to make it debuggable. Or maybe it's an issue that you want to debug an issue that happens only on certain condition and you are not sure what they are. So when you detect it on an instance, you want to jump on it and start to debug it. But you can't start all your applications with the debug flag. It has massive performance impact. So what you want to do is send a signal to the process to tell it, hey, you are running in a usual setup. Can you transfer and become a process running in a debug session? So I totally apologize right now for all the Windows users. This talk is really oriented toward Linux and Unix for this comment. So if you want to tell a running Node.js instance to go in debug mode, you first need to know its PID, its process ID. It's the unique ID of the process on the hardware, on the machine, on the system. So you will use the ps command in Unix, ps-aux, that gives you all the info you need. And usually I use it with pipe grep node, so I only see the Node.js instances running on my machine. That gives you the results, multiple lines, with the one you see in the second chunk of code, which reads like V de Turckheim 603005, a lot of numbers, and then node server.js. Basically, de Turckheim is the name of the user owning the process. In that case, it's my user on my laptop. Then the number is the PID of the process, the unique ID to communicate with this process on the Unix machine. Then you've got data about the CPU usage, the memory usage, and eventually the last thing on the line, node server.js, is actually the command used to start the process. And then we will kill it. No, just kidding. To send a signal to a process in Unix, you can use the kill command and pass an argument to tell which signal you want to send. So here we will use kill, but we will say use -usr1, meaning don't send the kill signal, don't kill this instance, but send the signal that actually is named usr1, that is defined by software. And in Node.js, usr1 means let's switch the process to debug mode. And then you put the PID, so the system knows to which process the signal must be sent. And then you will see in the log of the application, the log saying debugger listening on WebSocket, blah, blah, blah. Meaning that the process is actually turned into going into debug mode, which is what we want. Then when you have that, you can open the Chrome DevTools and going on the URL Chrome in Google Chrome only and Chromium, Chrome://inspect. And I think it's time for the first live demo of this talk. But because this is a remote talk and I'm trusting my internet connection and I still want to take some risks, and I want to, like without any safety net, I will go by doing that on a remote instance of Node.js. So instead of just starting a process locally with --inspect, what I will do is I will connect on Heroku and take an instance that is running normally on Heroku and start a debug session from my laptop to the instance running in the cloud. Let's go. So can you all see my screen? Yeah, I hope so. Here I've got a Heroku application. It's a standard Node.js application. I did not go on the free plan because I wanted it to run when I did the demo, but otherwise it's a standard application. So let's just open the logs because we want to see them. Here you can see the app just started. If I do a couple query on it, I've got more logs, like there have been a GET request and /mem/literal, standard Node.js application running on Heroku. I'm even using a deprecated dependency. I'm really Node.js user. And as you can see, the application just started and it's not written that the debugger is listening to anything. And if I go on Chrome inspect, it doesn't detect any instance. So what I need to do first is to connect to Heroku in SSH to the server. I need to connect to the server where the application is running through SSH. To do SSH on Heroku, it's actually pretty easy. You will need a tool named the Heroku tool belt. That's basically the CLI for Heroku. And then you will run a command named ps:/exec. It basically means into Heroku, and that's Heroku specific. It says, hey, can you start a SSH session between my laptop and one dyno of this application? And then you put --app to tell it which application you want to connect to. Of course, I am logged into Heroku with the CLI first, so Heroku knows what my user account is. So when I do that, and now it starts to get risky because I'm doing things on a remote server, in a talk, things you should not do. It says, hey, you are connecting to web.1. It's the name of the dyno. If you have multiple dynos, you need to select which one you want to connect to. On demo April 2, that's the name of the application I created just for this talk. So remember, we want to do ps:/aux because we want the list of the process, because we want to identify the process of the Node.js process. So here we've got a list of process. First of all, we've got the user account, the PID, CPU, memory things, and then the command used to start the process. So we are looking for a command starting with Node. And here it looks like it's our command, the Node server we are looking for, Node server.js. So we check the PID, and the PID is 52. So now we can send the signal, so kill user1, and then 52, and nothing happens. Okay, nothing happens, but maybe that's expected. Let's see the logs of the application. So if I go on the log of the application on Heroku, I can see that there is a new line of log, debugger listening on WebSocket, localhost 9229, the URL for help, go on documentation. So yeah, we managed to change the state of the Node.js process. It went to running in the usual way into running in debug mode, meaning you can connect now the inspector to it. But here it's still not available in the remote targets. And that's actually expected. So let me log out. So there is something interesting, is that remote target can listen on any URL you give it, but I can't just give the URL of the Heroku instance to Chrome, because Heroku does not open the port to the whole world. The only ports Heroku opens to the whole world are the HTTPS ports. So I cannot use a WebSocket client to directly connect to this server. What I need to do is find a way to make this port on the remote server available on my local host, on my local machine. And thankfully, there is a solution through SSH for that, and Heroku exposes it in its client too. It's called port forwarding. So what you want to do is to forward the port 9229 from the remote instance to your laptop. So you use the command ps:/forward and then the number of the port. So if I do that, it will still take a few seconds to connect. And then it tells me that it opened a server on port 9229 that is forwarding to web.1. Remember, that's the name of our dyno, 9229. That means that on my own laptop, on my own computer, my MacBook at home, there is currently the port 9229 that is opened, and any connection I would do to that will be just forwarded through SSH to Heroku, and I would not need to know anything more. So now when I get to Chrome, I see that there is a Node.js instance that is available. Once again, I'm on Chrome :/inspect. And here I see that there is a Node.js instance connected to my local computer. So if I connect to it and I try to run in the console, I try to get what is the host name of this instance. And it tells me it's all this thing. And that's not the host name of my laptop. It's the host name of the Heroku server that is running on AWS Cloud. So I actually managed to connect remotely through the dev tools, and I can now browse the source of the code, get the memory, get the profiler information, run anything I want in the console. I can do anything I want through Hello on this instance from my laptop. Let's say I want to go back to Heroku log. I see that the console.log hello I did is available directly in the logs of the instance. So when I've done what I want to do on the Heroku instance, I restart it because I don't want it to stay in debug mode for performance reason. And that's the first part of my talk. With the live demo of connected to Heroku, it was the hardest demo and we survived it. So there is an alternative way to connect to connect to a debug session. It's using the inspector module. The inspector module is a module available directly in Node.js. So you do require inspector and it will be available. And it's actually a client for the Chrome DevTool protocol. It enables you to run the DevTool protocol on the local instance if you want to debug Node.js from Node.js, or on another V8 if you want to debug Node.js locally remotely, like another Node.js instance, or even Chrome or Chromium, you can debug from Node.js with this core module. So if you want to write CLIs or tools that automatically detect memory leaks or CPU bottlenecks with Node.js on another Node.js application, that could be a fun follow-up for this talk. So now let's go to the practical part, because we know in theory how to connect to Node.js application with the debugger, and now we need to know what can we do with it. And the first example will be debugging memory leaks. So let's say you are checking in your monitoring tool and you see that the instance, the server restarts a lot. So since you are a good developer, a good DevOps, you decide to check the logs. And the logs are actually really, really helpful because you see that the application crashes with these logs. Okay, these logs might be a bit complex. At the top, we've got a section named last few GC for garbage collections. Then we've got a section named JS stack trace. We expect some JavaScript code, and there is at least no JavaScript code in it. It's C and C++ code, so it's not really helpful. And there is actually one line that is extremely important in these logs, and that we really want to see. It's this one. Fatal error, ineffective mark compacts near heap limit allocation failed, JavaScript out of memory. The important part, the part you want to know about, is JavaScript out of memory. This means that the process crashed because there were too many things in the memory. So there is probably a memory leak or a too big memory exhaustion. We need to know what's happening into the memory of the process. And we know it's the JavaScript memory that is too big. So we want to understand what's inside so we can understand which part of the code generates too much objects that crowd the memory and that the garbage collector cannot fix. So let's collect what's called a heap dump. What's a heap dump? Glad you ask. A heap dump is a file showing the contents of the heap memory of V8. Basically, it contains all the JavaScript memory of the process. It might contain sensitive data. Let's say you are comparing passwords and you decipher them, or before you hash passwords, if they are not garbage collected, they will be there. Every piece of memory of your process will be available in a heap dump, but we will see how to make them a little bit safer. And my math teacher in high school used to say that example is better than speech. So let's go for a second live demo. And I'm expecting all of you to be cheering behind your laptops at home and people around you being surprised. So let's go to this live demo. Let me just start a local server, and here it is. So in the previous talk, you were introduced to autocannon. And I will use another tool that's basically the same thing as autocannon, but it's named AB for Apache Bench. Basically, it makes a lot of requests on an HTTP server. So I use the -C argument for concurrency and the -N argument for number of requests. This means, can you make 15 requests in concurrency until you reach 10K requests on this server? So let's do this. So now it's running requests. We can see it's already halfway done. I will use this time to drink a bit. And it's done, and we have the percentage of requests within a percent time. Okay, that's interesting, but that's still not a memory dump. Vladimir, stop lying about what you're showing. Okay, I will be showing a heap dump now. So here, since I started my application with the --inspect flag, I can see that it is actually running and available in the dev tool. So I will open the dev tool and I will go to memory. Okay, it's pretty empty. What we want to do is we want to click this button that does take a heap snapshot. But before that, we want to call this little garbage, which means, can you please trigger garbage collection, meaning can you remove all the content of the memory that is actually removable. That's actually pretty important because first of all, we can remove secrets that are not supposed to be leaked. And we can actually remove noise because in the file we will collect, that will be really noisy. So we click on the button to collect a heap snapshot. And it takes a bit of time. And that's pretty much why I did that on a local instance, because if you do that on a remote Heroku instance, it takes like 3 times the time of that. So the first thing we need to see is, if you see my mouse, is the size of the heap snapshot. Here it's 70 megabytes. And we have all its content. So inside it, we've got the content of everything in the process, sorted by constructor. So for instance, we know that there are like 143K objects in the process, and we have 15 instances of set. We have a lot of URL inside the process. Okay. We can check the columns quickly because they are interesting. The first column is actually the size of the item. So if I take this object, I know it has a size of 24 bytes, but it's its own size. It also has what we call a retained size. The retained size is the size of all objects that are actually, that can't be garbage collected because this object, 73.4 blah blah, has a pointer to them, meaning that if you are able to garbage collect this object, you will be able to garbage collect this amount of memory. And the second part of the panel is interesting too, because that's the retainer, meaning if you take an object, you can check every object that has a pointer to it and prevent it from being garbage collected. So for instance, this object, I don't know what it is, I have no idea what it is. Looks like it's a library. Okay, it's a library, and it's held by a lot, only type 9 in another object. Okay, so we are still trying to hunt a potential memory leak. So the second thing we will do is we will add more traffic to the application. So we run A/B again. That's enough. And we will collect a new snapshot. So this one is a bit longer to collect because there is even more things in memory, because remember, there is probably memory leak in that example, otherwise my talk would be useless. So it takes a bit more to compute for the tours. So let's see the size. You see it's almost 100 megabytes, and we were at almost 170 megabytes. Once again, we don't really see directly what's leaking. So what we do, we use comparison. And when we do comparison with snapshot 1, it actually tells you what objects are available in the new snapshot that were not in memory in the first one. So we have new columns, we have number of new items, number of deleted items, the delta of items, and we also have the size delta for the items. So what we want to do when we look up for a memory leak is find the biggest size deltas. So it's probably an object because closure and arrays are internals of V8. So we see that we have a lot of new objects. So let's check these objects. Okay, we see that we have a lot of objects that are 2088 in size. They are probably the same kind of objects. So let's quickly look inside. Okay, it seems to be an HTTP request. We can recognize it because it has the class incoming, and you need to know a lot about Node to do that, but it's pretty coherent with the fact that I've got also a lot of incoming message in my memory. An incoming message and server response, you better know them in Node.js under the name rec and res. Rec, the HTTP request, is an instance of the incoming message class, and res, the HTTP response, where you will write the response, is an instance of server response. So I see that there are a lot of them staying into my application, and that's actually really, really weird, as if they were kept in memory. So let's click on this one and try to find its retainers. So we can see that it has a retainer here, and each time we've got items, we have the line of code where they are created. So this is Node internal, this is Node internal, okay, this doesn't look like Node internal, namely literal. This looks like user code of my application. So we click on it, and it will actually bring me to the source code of the application. And here I see I've got an express controller, and each time there is a request getting inside, it calls getObject on rec and gets the UID back. So let's see what getObject does. It creates a new object with, as a first parameter, the request and then a UID, and then it adds it to a store. But I don't see any code where things are removed from the store. So that's where the memory leak happens. We are writing in this store, but we are never removing from it. So here we've got a memory leak. I will just quickly show you something really interesting that could have made our life even easier. So I just benchmarked another endpoint, which does exactly the same thing, but with one small difference is that it creates the object differently. I will explain you right now what this means when the snapshot is available. It will take a few more seconds, and that's why live demos are dangerous, because you lose time in your talk, blah, blah, blah. And now we do comparison with snapshot 2, and we can see that there is a new class named item, and there are a lot of them, like 2,000 of them. So if I click on it, I see that this is a class that is leaking, that the object instantiated from this class are leaking, and I already have the stack trace here to call. So it's like exactly the same code as before, but instead of creating the object with just bracket, we create the object with a class. And it makes our life way easier in terms of debugging, because we directly see what is leaking inside the application, because the heat dumps are sorted by class. Sorry, I stopped sharing my screen. That was not what I wanted to do. So let's go back to our slides. And now let's move to CPU bottlenecks. That will be a shorter part. So let's start with another story. You see in your monitoring tool that your server takes a long time to answer certain endpoints. And don't forget that in Node.js, in the list of best practice, the first one is always don't break the event loop. Actually, Node.js is single-threaded, meaning that if you've got one single synchronous operation that takes a lot of time, your server will be blocked doing only that. And it could jeopardize the whole application. So when this happens, to debug it, what we want is a CPU profile. What's a CPU profile? It's a file that will tell you which functions are running at one point. So during the collection time, the profiler will sample every n milliseconds the name of the currently running function and why it's running. This will highlight the functions that are slow, but the fastest function won't be shown because it's like a ticking system. And if a function runs quicker than the ticking system, it won't be shown. It will follow the JS execution, meaning that asynchronous operation will actually have an impact on it. And once again, I think it's better to go directly with a demo. So let's go back to our application. I will run an HTTP request at a certain endpoint, and I used the time method to know how long it takes. And it looks pretty slow. Should be good now. Please don't demo effect by running forever. Come on. No, it should be now. Okay, so that's a total demo effect, and something had to go wrong. So it ran for 22 seconds. So let's reduce the size of the string. Okay, let me do something quickly. Okay, better. So now it should run in approximately 7 seconds. No, yes, 7 seconds. Okay, so now I just restarted the instance. Let's connect back to the debugger, and this time we will use profiler. Profiler, it's not a one-off situation. Profiler, you start it and you stop it because you record what's happening over a time frame. So we will just start it here with start CPU profiling. We will trigger a request because we need something to happen while we are profiling. So you need some activity, otherwise you won't see anything. We wait, and now we stop the profiling. And it gives us this weird file that we call a flame graph. So I will just look up to the very first part of the flame graph. Please do. So a flame graph actually is a stack trace with time. It tells you here that the function onConnection has called the function socket, that has called the duplex constructor, that has called the writable constructor, that has called event emitter. And then you see there is an asynchronous operation. So the stack trace is broken and we need to go there. It has called emit, it has called all these functions that have been called. We have another asynchronous operation and we call that. And we've got the time. So here I can see that it has been running from 3.5 k milliseconds up to 12.5 k milliseconds. And I know that the functions here have been running for a very long time. What's important is the function at the bottom or at the top of the flame graph. So in our case, it's at the bottom because it's a top-down flame graph. So once again, this function has been calling this function, that has been calling this function, until this function has been calling this function. You can see that this function is named module.export, and that's probably not a great name if we want to debug. It probably would have been better if I gave it a real function name. But at least this function has been calling a function named validate input. So let's click on it. And here, Chrome tells you, hey, this function has been running for 10 seconds, 9k milliseconds. It's probably really, really slow. And that's actually this line that has been really, really slow. And if Liran or anyone who is used to Node.js security is looking at this code, what they have seen is that this regex is actually what we call a backtracked regex, meaning it contains a redos, a regex dos. Regex dos is not the toggle of this talk, so feel free to check it. What you need to know is that it's a regex that can run for very, very, very long time. And since it's running for a very long time and it's JavaScript and synchronous, the server is blocked on running this regex, this exact regex, for a very long time and cannot do anything else. So to fix this problem, you either have to update the regex or time bomb it. I recommend to check the module named VM in the core of Node that enables you to time bomb synchronous piece of code. That's really powerful, but highly unused. That's a great hack. So thanks to the CPU profile, we were able to detect where the leak of CPU happened. And here you can see they look very, very small because the other function have been so slow. We have the method that are called for answering the HTTP requests. Okay, let's go back to the slides because the talk is almost finished now. Please let me share. Okay. So let's wrap up. I hope you all love the Chrome Dev Tool now because they are probably your best friend when something goes wrong. So in wrap up, I usually give a few advices to the users. We have 5 more slides. So the first advice I can give you is monitoring, monitoring, monitoring. If you remember, in both scenarios I gave into this presentation, they started by monitoring gave us something weird. Monitoring told us the application was crashing. Monitoring told us the endpoints were slow. Monitoring, monitoring, monitoring. You have to monitor performance. You have to monitor for security. You have to monitor for the infrastructure, because otherwise you don't even know the first thing about the health and the security profile of your application. Second one, use classes. Don't create objects out of the void. Quick parenthesis, all these tips works not only for Node.js, but any JavaScript application, because the methods of debugging I showed you today are also available for front-end application in the browser. You can't connect to the remote, but you can always start a web page and open the Chrome Dev Tool for this page. So use classes. I know it's not popular amongst React people, but use classes. It will save your life in time of memory leaks. Name functions. Naming functions is the best way to find it easily in a CPU profile. So here I created dummy code examples, and it was pretty easy actually to find the problems. But in the real world, your code is much more complex than my dummy applications that don't do anything. So name things, give them class names, and you will be saved. Don't panic and trust the engine. V8 is like one of the best pieces of engineering ever made, and you can trust it to save you and the tools around it to make it up for you. Human write code, human make mistakes. This will happen in production for you. Maybe not today, maybe not tomorrow, maybe not in Node.js, maybe in Python, maybe in Java, but these principles are the same for all languages, all platforms. This will happen to you. For instance, you can read the great blog post about from the Discord team that explains they switched from Go to Rust because they had a different memory management model, and they had to understand the memory management model of Go to understand why their application was slow. Also, if you're interested in the performance of Node.js, you can check the blog post by Netflix. They've got one of the most amazing teams in the world regarding these topics. Debugging, and that's the last quote of this talk. Debugging, it's like being a detective solving a crime, but you are also the criminal. Or if you are not the criminal, it's one of your coworkers. So when you write code, don't forget to write it as if the person who will have to fix the bug is a maniac who knows where you live. And also when you write code, think about not dying when things will go wrong, because that's where you will lose time, you will lose money, and you will lose customer. Thanks so much for your attention. I assume you have been an amazing crowd, but it's really hard to say. I'm sure you have been. So let's keep in touch. You can email me or contact me on Twitter. I'm very present on Twitter. It's really hard to give swag on a remote conference, but I tried to. So there is a Node.js security checklist. It's a free checklist of the list of things you must check if you have an application in production using Node.js for security. Check it, it's on Sqreen blog. The slides are directly online, so feel free to Google them. And here is the link for the Q&A. I think it's on the chat for the...
Yeah, that's exactly what I sent to the chat, so I suppose people already seen it. And I loved your spontaneous jokes, really. It
Thanks
was
so much.
It's because I understand how hard it is to speak to basically no one, so you try to mingle it, and it was amazing. So thank you for such an amazing speech. You did a great job, I suppose. So and, yeah, I suppose you may go to the QA room
Okay.
and wait till people will go there and ask you some questions.
Thanks so much for having me today. Thanks so much for being an amazing host, and have a great day, everyone.